This next topic is key to how SolidWorks simulation solves engineering problems. The fundamental equation solved by SolidWorks simulation maybe looks familiar. It's an equation we use to describe a spring, maybe in a high school physics class. The idea is when we apply a force, we get displacement. And the amount of displacement we get depends on this proportional constant called stiffness. So what is stiffness? Let's say I've got two springs. One is pretty short and bulky, and the other kind of long and lanky. Very thin as well. I apply the same load to both of them, 100 pounds. Do I get the same displacement? Well, it depends on their stiffnesses. This spring is pretty stiff. It has a stiffness of 50 pounds per inch. This spring is a little more flexible. It's got a stiffness of 25 pounds per inch. So if we use the stiffness numbers that we determined to calculate how much displacement we get, we take the 100 and divide it by the 50, and we end up with 2 inches in the top case. In the bottom case, take 100 divided by the 25, we end up with 4 inches. You can see more displacement in this long, slender spring versus in this stiff spring that we have here. Let's see if we can get an idea of what stiffness would be for a simple shape like this rectangular brick. If I were to pull on it in these two directions, what should its stiffness depend on? Do you think a small area is stiffer than a big area, or vice versa? So I would expect the stiffness might be proportional to the area. You double the area, you double the stiffness. It's twice as much material that can take on that stress. What about the length? Well, if you double the length, it makes it more flexible. It's like having 2 of these bars both deforming, contributing to that displacement versus just one of them. Stiffness is inversely proportional to the length. And also, the material makes a big difference. Whether or not it's made of steel or aluminum, steel is about 3 times stiffer than aluminum on average. So it really boils down to a material property we described earlier, the elastic modulus, that describes that material stiffness. So for simple shapes, we see we can come up with stiffness values for those, and we can really take advantage of this concept to build complex codes like SolidWorks simulation, which we'll see in a moment.